If you switch your hot end to a little higher grade hot end, would that help your retraction settings? This subject can be a little tricky, so bear with me on this one. But I'm going to go ahead and make a blanket statement. These usually come back to bite me by the end of the video. But I'm going to say yes, switching out to a little higher end hot end should improve your print quality and print speed. Now, a printer like the Ender 3 are kind of known for high retraction settings. That's because of the Bowden setup, and the PTFE tube goes all the way down to the nozzle. So you have to set retraction kind of high to be able to get good print quality. And before we go any further, let's check out what the stock print quality looks like. This is from my Ender 3. I do have cap tube and an EZR extruder, but that's pretty close to stock, and you can probably tune your Ender 3 to get really close to this result. Very light stringing. This is Prusament Azure Blue, but a very respectable print. The only downside is this took 1 hour and 59 minutes. That's because my retraction is at 6 millimeters at 25 millimeters a second. So the retraction length is pretty long, but you can still get a decent print. It is important to note again that I have upgraded to the CME CNC EZR extruder, and I have cap tube TL all the way down to the hot end. But that's the idea here. Hopefully we can switch out to a better hot end, we can reduce the retraction length, hopefully reduce print time, and increase print quality. And I am, against my better judgment, going to use the Mosquito Hotend on this Ender 3. And the only reason why I say that is because this hot end costs about the same as this whole printer. But if I always did things that made a lot of sense, I probably wouldn't make as many videos. So there are quite a few steps we're going to have to do here, but the first one is switching out the Marlin firmware. This is still the stock firmware, and we're going to have to change to something we can update because I have to update the Termistor cartridge. I am going to use the Slice Engineering cartridge, so we'll have to add a temp table, but even if you use the E3D, you're still going to have to alter the firmware to be able to use it reliably. So that's a great place to start. Let's go ahead and upgrade the firmware on this Ender 3. As we've done many times before, let's head out to marlinfw.org and we'll download a new version. We're going to stick with 1.1.9 for this project. We'll head to Downloads, right-click Extract All. Let's call this one 9_Ender3. Extract All. The extract is done. Let's head into the folder. We'll head into Marlin. And fortunately, the Ender 3 is a pretty easy one because there's already an example config for it. So all we have to do, head into Example Configs, head to Creality, head into the Ender 3 folder. You can do boot screens and status screens if you'd like. Let's just go ahead and take all 4 of these files. We'll right-click and copy. We'll jump back up a level, up another level, back to the main Marlin folder, and let's rename our configuration file to configuration_old, and same with configuration_adv.h. Configuration_adv_old. That way we'll still have a copy of the stock one in case we need to refer back to it. Then we can right-click and paste all the Ender 3 configuration files. Basically that's all you should have to do. These configs are usually pretty good that come from the community. So most of these boards don't have a bootloader, and you're going to have to program one to be able to load Marlin. So we're going to do that with an ISP programmer today. You can do that with an Arduino the same way. I do have a video on how to do it with an Arduino. Just check that video out up in the corner. They should come with a cable. We'll just plug this side in right here. We'll go ahead and cable up to our computer, USB. Green light should be a good sign. And if you're using the programmer like I am, you're probably going to need a USB tiny ISP driver for Windows. You can just search that, but I will leave a link in the description. So we'll grab some drivers. This one should work just fine. Download's complete. We'll open it up over here. We'll agree. The default should be just fine for this programmer. Go ahead and hit install. Yes, we'd like to install the device software. And we'll hit close. Now if we head into Control Panel and go to Hardware and Sound and Device Manager, you should have a USB tiny device with no warnings on it. We should be good. And here's a look at the printer side of things. These are the pins that we need to hook up for our programmer. This pin right here is the 5-volt pin that needs to be hooked up to VCC on your programmer. The only problem is the cable that I have, it's too tight in here to hook up the cable directly. So you can either do some DuPont jumpers and hook up your cable that way, or the way that I'm going to do it, I'm going to remove the LCD cable and the housing that's around those pins just temporarily so I can use my programmer. Probably not the safest way to do things, but it's the quickest for right now. So I'll remove my LCD cable. I'll gently slide this holder off, and then I'll plug in my programmer. The red wire from the front will go to the right side. And when you're hooked up, you'll see a little blue light. That's a good sign. Just remember, when you put your housing back together for your LCD, the little notch on the cable goes right there. So let's head back into our Marlin folder. We'll go ahead and open up the Marlin INO file in the IDE. You will need the Arduino IDE. As always, links in the description. And in order to provide you as much information as possible, I'm going to turn on some of the verbose logging in the IDE so I can show you a little bit more about burning bootloaders. So I'm going to go to File, Preferences, and I'm going to make sure that Show Verbose Output during compilation and upload is checked, so we can see a little bit more about what we're doing. Now you will need the Sangino board library to be able to flash this board. I do that in another video. There is a link for that. But before we flash the bootloader, I want to show you what it's like when a board doesn't have a bootloader. So I'm going to cable up to the printer USB. I'm going to jump into Tools. Again, Sangino, I have the library installed. It's all the way down there at the bottom. Processor, you want 1284, 16 megahertz, that one right there. Since I plugged in the printer, it is on COM11, so all that's set up. We're going to jump back out, and I'm just going to hit Upload. And since we have that verbose logging on, we're going to get a ton of information down here in the window. After the compile is complete, it's going to try to start uploading the sketch. So when the upload starts, it gives you the COM information and the baud rate, and then it's going to try 10 times to contact that board. When you see programmer is not responding, that means there's no bootloader on this board. So if you have a board that you don't know if it has a bootloader on it, just prepare your Marlin sketch and then try to upload, and if you get these errors, then you know you're going to have to burn a bootloader. If you have a bootloader, it should just upload first time, no problem. Now that we know what it looks like when we don't have a bootloader, let's flash a bootloader. I'm going to go ahead and remove that USB cable that I used to detect the bootloader. We don't need that, we just need the programmer plugged into the ISP. The programmer is plugged in USB to the computer. Since we have our Sangino library already, we can just go to Tools. Again, make sure you're on Sangino. You have the 1284 16 megahertz processor. You notice there's no port right now because I've unplugged the printer from USB. We need to come down here and make sure we're on the right programmer. USB Tiny ISP is what I'm using. And then you should be able to just hit Burn Bootloader. It only takes a couple of seconds. Again, we have all this information down here, and you'll notice we got an error. If you scroll back up a bit, you'll see writing 100% right here, and the part that errored out was the verification. Now technically the USB Tiny ISP can only handle 64K. We're trying to do 128. So the verification failed. It couldn't verify that load. But the bootloader did get loaded successfully. You can see in all this information above. And the easiest way to check that there is a bootloader installed is to just try that upload again. So we'll uncable our ISP programmer, we'll put our LCD screen back together and get it plugged back in. Then we'll cable up to the printer USB and turn it on. And then back to Tools. Again, make sure you're on the right board. 1284 processor. We are on COM port 11 now that USB is plugged into the board. Then we can jump back out and we'll hit Upload. You can see it's writing to the board. That means we've successfully written the bootloader and the code's being loaded. When the upload's successful, you should see your Marlin slash screen and we're good to go. So the bootloader's on and Marlin has been updated. Now we can come back whenever we want and update Marlin via USB. We should never have to touch the bootloader again. And we'll need to make some changes after we make the hardware changes, which is what we're going to do now. So let's get everything swapped out. I'm going to first go ahead and preheat the hot end so I can remove the thermistor, get some of the filament out of there, as well as remove the heater cartridge. While that's heating up, I'm going to go ahead and remove these two screws and take that fan shroud off. Be careful while that fan's running, you don't want to break any blades off of it. Now that the hot end's up to temp, I'm going to go ahead and remove my filament I have left over. I'll remove my PTFE tube at the hot end side. Right underneath here, you'll have a set screw that holds the heater in. And go ahead and back that out. Don't pull your heater out quite yet. And on this side, you can see the screw right down in there. That's what holds your thermistor on. We can go ahead and back that out. Once that screws out, you can go ahead and slide your heater cartridge and your thermistor out completely. And we'll just turn the printer off and let everything cool down. Once everything's nice and cool, you can go ahead and take these two screws out to remove the stock hot end. And we should be ready to start installing the Mosquito. So here's all the stuff that I'm going to use to install the Mosquito. Of course, we have the Mosquito Hotend. It comes with a 30mm fan. We have a mount that I've found on Thingiverse and modified for the Ender 3 and the Mosquito. I'll leave a link to that remix below. We have our Slice Engineering Termistor and an extension cable. And then we have a 6mm PTFE coupler that will hook our Bowden tube into. It should screw right into the plastic on top of the mount that I got from Thingiverse. We can go ahead and mount our Termistor before we put it on the printer by removing this screw right here. I'm going to use a little bit of boron paste for the Termistor and the heater. This is just to give it a little bit more thermal conductivity. I'm going to slide my Termistor in from the right side of the hot end because that's where the wires are on the Ender 3. Now I am going to remove the 30mm fan off of the Slice Engineering hot end. That's probably against the rules, but I'm going to use the 40mm that's on the Ender 3 just to make it easier to install. Also remember, the Ender 3 is 24 volt. So we'll go ahead and thread our coupler into the top of this mount right here in the center hole. Just like that. I did end up using a tap to put some threads on this because I was afraid I was going to crack the plastic. This is PETG, by the way, so in case there's any heat, it should hold up to it. And then the hot end will mount just like this. We can use the screws that came with the Mosquito. Should mount just like that. I'm going to remove the Captain tape and snake this Termistor back through this sleeving so I can remove it. The old Termistor's been pulled through. It plugs in right here on the board on the Ender 3, so we can just remove that. And that's where the new Termistor will go, on those two pins. Now we can go ahead and snake our new Slice Engineering Termistor with its extension DuPont connector first, back through the sleeving. Remember, we are still using the stock heater cartridge, so we're just going to leave that in place. We've got it snaked through. Now we can just reconnect it back to those two pins. Right there. It's probably also important to mention that I'm using a genuine E3D nozzle. This is a 0.4. And with the way that the Mosquito is going to mount, the stock hot end is actually going to be quite a bit shorter than the Mosquito. So we'll have to adjust the Z end stop to make this work so we don't get collision. Before I mount the Mosquito, I'm going to go ahead and slide the heater cartridge in. And I'll put the Mosquito retainer screw back on so it holds the cartridge and the Termistor in. So with this mount, the stock Ender 3 screws are going to be too long, so I'm going to use some M3 by 5mm screws and a couple of washers to attach it. We should be good there. We can go ahead and attach the Termistor connector. We can put our Bowden tube back on. Had to switch out that coupler because that one was faulty. And we can go ahead and put our fan shroud back on, but you're going to notice the Mosquito is a lot lower than the stock hot end, so we're going to have to extend this part fan duct out a little bit. And there's my reworked fan duct. It's pretty much just like stock, only I made it a little bit longer. I didn't want to change it too much because I didn't want to skew the before and after results. It shouldn't change it that much. We should be good to go. And since the nozzle's lower, I'm going to move my Z end stop up a bit, and then I'm going to do a round of leveling to make sure I don't crash into the bed. So we're looking pretty good. The Mosquito's installed. It is a little lower than the stock hot end, so I had to make the fan duct longer so that it could still do some part cooling, but I didn't want to alter the original design too much to maybe skew the results a bit. We'll see how that goes. I also raised the Z end stop up a bit so I wouldn't crash into the bed. We are using the Slice Engineering Termistor, so now we need to get into Marlin and add that temp table and re-upload the code. So back into the Marlin config files, I just so happen to have the files we need ready to go to add that Termistor. I do have a video on how to add a temp table to Marlin. You can get the link up in the corner. I know I've been saying that a lot this video, but hopefully these links are helpful. Links to these files in the description as well. So I'm just going to copy all three of these files, slide them over to the Marlin folder, and we'll replace. And then we can close the IDE and reopen it. If you go to the pull down, scroll pretty much all the way to the bottom, you can see we now have temp table 67. That's the one I created for the Slice Engineering Termistor. We can go to configuration.h and we'll change our hot end Termistor from 1 to 67. That should be all we need to do. Now we can go ahead and re-upload. Cabled up USB, printer is on, tools, board Sangino, processor 1284, 16 MHz, COM11, hit upload. Our upload's complete. Our Termistor is reading somewhere around room temp, so our temp table add was successful. So we're ready to go. Now all we need to do are some tests. So I'm going to start at the stock where we had it before at 6mm, and I'm going to work down the scale until the stringing gets kind of severe. Same filament, same G-code, except for the retraction setting. So let's go. Yes, benches were printed, things were time-lapsed, all is well. But there are a couple things to note before we take a look at those prints. Now when I upgraded Marlin on this machine, I didn't reload EEPROM, so the stock values for the Ender 3 are still in effect. And I mention this because the stock feed rate on the extruder on an Ender 3 is 25. Now you can go into your slicer and set the retraction speed, but you're never going to be able to exceed what's set in firmware/EEPROM. And if you do want to try to increase that speed to get your print time down, be careful with that setting, because the higher you go, the more probability you're going to have of stripping the filament when you're trying to retract it out. But with that said, let's take a look at some of these prints. So here's the benchy I showed you before from the stock setup. This is with the original Hotend. Again, not a bad benchy. It looks pretty good after you dial everything in. All of these benchies are at a retraction rate of 25. This one is 6 millimeters of length. Now this one is from the Mosquito. Again, all of these are 25. This is 6 millimeters of length. As far as retraction goes, they're about the same. But the one from the Mosquito, you can definitely tell it's quite a bit more accurate. If you just look at the layer stacking that's here on the wheelhouse, you can tell it's a lot more even than the one from the stock Hotend setup. Both took an hour and 59 minutes. Then we jump down to 5 millimeters of retraction. Still, as far as retraction goes, about the same. Not much difference at all. Quality of print is about the same. Can't really tell the difference. This one took an hour and 54 minutes. Then we jump down to 4 millimeters of retraction. Again, you really can't tell the difference in between 4, 5, and 6. They're almost identical. This one took an hour and 51 minutes. Then we jump down to 3 millimeters of retraction. Again, 3, 4, 5, and 6, almost all identical. No extra stringing. This one was an hour and 47 minutes. But then we jump down to 2 millimeters of retraction. Now we're starting to see where the retraction comes in. You can see where it's starting to stack a little bit of the filament when it's pulling the nozzle back to the hull. On the other side, you can see some of that same kind of effect. Even though this was degrading down the scale, I went ahead and went down to number 1. So the 0.2 layer height took 1 hour and 42 minutes. This one took an hour and 37 minutes at 1 millimeter retraction. You can see it's kind of a mess. So our butter zone is probably somewhere around 2.5 on the Mosquito Hotend. And to give you an idea of what increasing your retraction speed looks like, again, take a look at this one. This is 2 millimeters of retraction with a speed of 25. Again, an hour and 42 minutes. This is 2 millimeters of retraction at a feed rate of 50, so double. So the EZR was able to handle the extra speed, but this one only took an hour and 35 minutes to print. So that just shows you what increasing that speed can do. And for those of you that's been asking about PETG, this is PETG on the Ender 3 with my EZR. They come out a little bit stringy, but they still look pretty good. PETG is definitely doable on the Ender 3. And trust me, there are a lot more test runs than that. Those are just the ones I found interesting. So the all-metal Hotend has definitely improved our print quality, allowed us to reduce our retraction length, and our overall print time. But a note on all-metal Hotends. That includes the Slice Engineering Mosquito, the E3D V6, anything that doesn't have a PTFE liner in the barrel. PLA likes to stick to it, and that can cause jams. But there's a couple things you can do to get around it. 1, lower your retraction length. The less you retract, the more unlikely you will be to get into a cooler zone that might cause a jam. 2, make sure your Hotend fan is up for the task. You want plenty of cooling on the heat sink of the Hotend to keep this from happening. And 3, you can do what they call season the Hotend. Basically, you're taking some filament, dipping it in some cooking oil, and extruding it. That should help keep the plastic from sticking to the metal. You should only have to do this once in a while. And I mention this because if you're used to using something like a Prusa, it has an all-metal Hotend, an E3D V6. It has a direct drive extruder with lots of power. And you might be clearing this jam just with the extruder and not know it. But on something like an Ender 3 that has a Bowden setup, you're not going to be able to put enough pressure on that tube to clear the jam with the printer. you're definitely going to have to manually intervene if this happens. Just something to think about if you're considering this upgrade. And again, I just used the Slice Engineering Mosquito on this upgrade because I had it on hand. There's probably a lot of other all-metal Hotends out there that you can achieve the same results. I hope you liked this video or you found it helpful. If you did, please consider giving it a thumbs up or subscribe to my channel. If not, leave your thoughts in the comments below. And as always, thanks for watching.